Good morning, people. Welcome back to the SketchUp drawings. Well, the Dave's Diary entry at least, and the jobs out in the workshop. Now, I've been talking a heck of a lot about it, but I haven't yet got have the videos loaded that talk about the MFT top specifically. Generically, yes, but not specifically. And I thought I would get ahead of those videos with this lovely model highlighting what and why I want to do things this particular way. Let me just check first. I'm just checking the profiles. One of the things with SketchUp, it's got this default setting which doesn't make the drawings look as attractive, as I found out many years after having been using it. Right. The problem. Didn't know it at the time. So I bought a drill holding jig that would allow me to drill accurately the holes in the tops for my MFT style of top and all these accessories. Unbeknownst to me, and only came apparent when I did some test holes, the hardness of melamine coated or covered custom wood is such that it makes you have to really, really hog down onto the drill to punch through that very first, very fine layer of melamine. Now, what that does is the jig, I'll explain a bit further. The jig has to be held with one hand, the drill with the other, meaning you can't really neutralise the pressure down onto the body of the drill as you would if you had two hands free to do that. But when you do push down with one hand, you do stand the chance and the reality of canting the drill off on a slight angle. So once you have drilled the holes, the hole isn't perfectly perpendicular or square to the surface. Very small, and for most cases that would never ever be a problem. It wouldn't be a problem if it was a solid timber top, a plywood top, a custom wood top, but it is with a melamine coated custom wood top. And critically important when you're drilling through multiple layers that need to be aligned accurately with the pins. So, I inadvertently found the issue specifically to the way I'm building this top, and if you too are using melamine coated material, you may benefit from this video. I decided, and I'll add another layer, I'm not making one big MFT top, MFT style of top, but rather I'm making, turns out, components that make up that top, and there lay the solution, unbeknownst to me. And that was, I can create strips of melamine, 300 or 400 millimeters wide, bigger, but with more difficulty, and I'll get onto that in a moment. But with those 300 and 400 wide strips of melamine, effectively offcuts or waste from the joinery industry, I was able to make quite a big MFT style of top, which I have talked about in the videos. Now, I actually might just draw in another model just to explain where I'm going with this. So if you just wait there a moment, and here in front of us is the considerations that I'd, created. These were the earlier versions and include a lot of the mullings over of what I was going to do. Using the track saw rail, the fences that are pinned into place, and the MFT style of top, I was going to have a very versatile, capable system. I'm going to call it a system, because as I further went along the process, I developed it a little bit further, which you'll see in a moment. Originally, I had the 2 layers, which I still have, but they were going to be registered together with dowels so that they didn't move. The top layer, this one here, would have had pins running along here to register it to the bottom layer, redundant. And this was going to be redundant. These were running in a combination of parallel to the units underneath. I'll just hide those, like you can see here. And with these ones, like they are now, running at 90 degrees, they would dowel together and hold everything together. Again, redundant. I'll explain why. When you no longer have these running parallel, but running them 90 degrees, any bench dogs put into the 2 tops hold it together anyway, so you don't need that backbone of registration pins. And that's what I was calling it. It was a spine or backbone of registration pins. But this way, not so much. Not required at all. What I did do was dowel together the bottom layer so that they effectively created one big sheet. But with the facility, as you can see here, this 300, then a 400, then a 300, they can be pulled apart when not needed and popped up on a shelf. And I will mention that many times in the future, so get prepared for that. Ditto for the top layer. They can be of a shorter, in this case 1200 or 1220, 4 foot wide, and hey, that's just actually the width of a sheet. Oh, how convenient. And they can be, again, also taken off and popped up on the shelf when not in use. The whole thing literally stacks on a shelf out of the way, because there will be a large chunk of the time when this is not being used at all. However, it does have the benefit of being able to be put together in smaller combinations. So instead of the 8 foot, the 2440 long lengths running this way, I may only just decide to put the 4 foot or the 1220 wide pieces or long pieces together to be used, or on a separate top, which is going to be the case. Now, if I just draw in, close that, and I'll draw in this model, which is effectively the same thing with a little bit more of the system shown. And this is one of, again, unintended, but as I went through the approach, a very good addition to the system. And this is what I've been calling the parallel arm guide gauge fence gizmo. Doesn't have a proper, well, it is a proper name, I suppose. But that works, believe it or not, incredibly well with the track saw, and gets rid of one of the items that I'd bought for doing narrow strips, in my case, narrow strips. And I can go down to, well, you pick the width of the strip, let's just say 5 millimeters. Now, with a track saw doing repeat 5 millimeter cuts, I'm going to suggest is a little bit tricky, but not so with this. In fact, it becomes as easy as any other cut, period. So that in itself gives this some credence for perhaps you'd want to consider. Now, this is a model of the jig that I had bought, and it holds the 20mm drill bit for drilling the bench dogs. You have to hold this down. Once you have located this in the wee pinhole or spot hole that I would have made using the jigs that I've got, but this jig holds the, or tool, holds the drill bit in exactly the right place. One hand left on this side here, and the other one with the right hand using the drill. And when you push down on this, there is a very slight chance, as I said, of this cantering off on a tiny little bit of misaligned angle. Darn it. So, and this is something I hadn't mentioned, well, I alluded to, the difficulty of punching through the surface was quite high on me. And I hadn't realised that because of that bigger surface area, cutting through the melamine was quite difficult on the body. And especially if you were to reach out away from your body, and out in the middle of a bench surface, it would have been nigh on impossible to drill without probably getting up on the bench yourself and setting to, pushing down on it. So it turned out that I could create the solution to my problem. So, yippee. Now, just before I go on, I had actually anticipated making this out of steel. And this is this model here. I've got some 40mm by 10mm steel left over from my first attempt to do the bars that would have created the 3-4-5 triangulation method. And I didn't make a good showing of that, so I got some laser cut. But later on, I came up with an alternative solution. Anyway, 25mm custom wood. That's what I've come up with for this. I have to remake the current one that I've got, and I will, because I've realised that there is a certain process that makes it run better, and I'm getting I can dial it in so it is down to literally a fraction of a millimetre accuracy for parallel. Kind of needed. And the other day I went to line everything up and it was out. Don't know why. Physically shouldn't be able to. It does draw into questions a whole lots of possibilities. So I just thought, deal with what I've got currently in hand, and then as I go through over time, I'll find what or where the inaccuracies are or how they're created, and I can adjust accordingly. Right, so what was the solution to this? Well, the solution was, of course, being able to cut the tops down into the 300 and 400 wide pieces. Now, if you just wait there again, I'll find another model. And back again, once I found the model, it was hiding. But if I bring this one across, it explains the approach that I was able to achieve and get good results. My small drill press has enough capacity from the centre line of the drill to the post of the drill itself to get a double row of holes from one side and a double row from the other side, allowing me a 400 wide panel to be drilled with the 100mm spaced holes. It also means I can do a 300 wide, so two rows from one setup, spin the board round, drill the third set. To achieve very good accuracy, I've also got this facility for a lathe chuck and there's a reason I'm going here, but maybe I'm touching on it now so that when we get out into the workshop, perhaps you'll have that background. But if you chuck up a rod in the lathe chuck first, and then insert it into the drills chuck, tighten everything up, you've got perfect registration for drilling round stock, which happens to be the things that we use for bench dogs, isn't it? So that was a method that I wanted to be able to have included in the drill press itself. So then you can drill out holes for particular purposes if that was needed. This is not pertinent or relevant to the current video though, but I just had it there, so I'll mention it. But having this top like this that is adjustable, and I made some adjustment here so that I could tune it in perfectly square perpendicular to the drill axes, then I could lift or lower each end with the adjustments that are made in the bottom to achieve that alignment. And then I could drill my bars and my strips from MFT on this type of setup. Yippee. Now, I didn't have this specifically ready for my steel bars, but this was what I made for the MFT strips, MFT style of top, strips. So, yeah, because you do not want to have long lengths. Remember, 2.4 meters long. You don't want to be having those balanced on a little steel table like this. So I made this very much longer, bigger top. It worked really well and allowed me to do a lot of holes, probably in excess, well, around about 550 to 600 holes for the components. Right. Get rid of that. So we're back to that. We've covered this drill jig, the parallel arms, the 300 and 400 wide pieces there. So the pads that I want to make, these golden coloured pads, can either be the MFT top or a separate pad that goes onto the MFT top. On that surface, there are these blocks that are dimensioned to perfectly locate these two different sized items here in black. It has the item elevated up off the ground so that the pressure points only rest over the joints and don't interfere anywhere else. Just on the off chance that we want to put the pressure there to flush it up. But mainly, it's so that being elevated like that, I can get a drill chuck in here and I can pilot drill the holes necessary for any screw fixings or nail fixings that I deemed required for this particular item. And that was the main, the two reasons. Elevating it to put pressure here so it doesn't interfere anywhere else, just in case there's some imperfections somewhere in the machining. But yes, to get the drill in there to be able to get in there and put a hole in the bottom and in the top. So that's what they are there for. Pinned, in position. These can be numbered off as whatever way you want to annotate them for this particular jig. And as likely, they could be made to be a little bit universal in use, but when I drew it up, I've just made them so that they go together as a set of four. This double one here counts as 1, 2, 3, 4 pieces pinned into place because we've got the reliability of the holes underneath. We can put as many holes as is required to locate this. And then we've got our jig, which isn't dependent, as it is at the moment, on having a piece like this and a piece like this set up for doing these items. I can actually just use these components, put them in a box somewhere, put them into place on the MFT top or a pad, and well, yeah, use them for as long as I want them, then pop these off and I'm back to a standard setup for some other item not requiring this particular style of jig. Straightforward. And then I was contemplating about having a multi-use plate for putting in blocks for clamping, and I'm looking at that. Not overly impressed with my output of that so far. Then I came across this idea using the steel piece here, straddle blocks that are pinned in place, so that's for accuracy, and having a fitting that allows part of that drill jig that I'd mentioned, that one where you have to hold, the one in red, I can actually take the fitting out of that holds the drill bit and put in here, because they're all of the same thread type, a 14 by 1mm thread. That way I can put the drill in this setup. This is now pinned in place, pinned in the bar. This is the bar that the 345 or part of that system, again pinned in place, and allows me to drill holes anywhere on any size top. Yippee! So, yippee! Now, What I found though was rather than using steel, strangely enough, I can use custom wood. And what I did is actually I bought a second jig, the very same jig that wouldn't allow me to drill into melamine for a couple of reasons. The drill bit itself would have paid for it compared to me buying one separately or of any good quality, and I get a second drill bit guide, the actual bearing bit that I can screw one in the top here and from underneath one in the bottom there, giving me a double length amount of holding for the drill bit itself, making a very nice alignment for the drill bit to be held. And using the, as I said before, like this one, I can pin these blocks into place on the existing top bit that I could get to with my drill bit, the drill press, pin everything in place and bridge that these two pads with this piece of melamine with the drill guides in place, and I can now drill wherever I darn well want or need to, on any size top. So I'm getting the best of a couple of worlds as far as drilling the MFT style of top. So yippee, no kidding. And it's meaning that the output that I can achieve is flexible. I can, at the drop of a hat, go from cutting down large sheets, a full-sized sheet, in fact. I've got it so that I can cross-cut the full width, 1200, 1220 wide. Can do that with the track saw and the MFT style of top. And I can do rip cuts, and then literally at the drop of a hat, after I've got those components, pop on these other items should I need them for the job at hand. And one of those jobs at hand I should be doing right now instead of making this video, where I'm cutting down already roughly sectioned or dimensioned sheets for a storage cabinet. And there are a huge number of cuts going to be required, and it's not going to be a small job. So, yay. And that is making use of the MFT top, style of top, the track saw, the different uses of the bench dogs, the parallel arm guide gauged fence gizmo, and then a dimensioning router, or worded a different way, a router assembled in a way that dimensions the panel edges with the parallel arm guides in the MFT style of top. So a jolly good system it's turning out to be. So I promote it a little bit. The sketchy builder gizmo or approach, whatever you want to say it. Well, that was a long one, but it has covered off a lot. And as I said, this is going to be a video that chronologically is out of order, but gives a lot of the thinking. In fact, at the moment I'm loading the videos where it's talking about the nut job, where I'm considering an alternative method for making the 3-4-5 triangulation method using threaded rod and nuts. That allows for any size of spacings, be it the conventional 96mm spaced increments or the 100mm, or even odd numbered, so like 71 for whatever reason. But it allows that to be created in the workshop reasonably straightforward, fiddly, very, very fiddly, but relatively straightforward, using components that you can get at the local merchants, rather than having to have specifically made CNC machined, laser cut machined items. And they use the same components for the 96 and the 100, 32, the 50, whatever spacings you deemed you require. So that is a major, major bonus and a cost saving. So there, and I'll be covering that, the MFT top, and all those other components I've talked about. Now, if I've already covered them in videos, my bad. But if not, well, as I said, I'm doing this, just to give you a wee bit of feed-in background to the items I'll be talking about. Righty-ho, that's it. I'll end this, have another cup of tea, and head out to the workshop to do some much needed and delayed work. Delayed by about a week. I've got to, or at least a week, so I've got to do some catch up. Rightio, that's it. I will see you in the next video, I would hope. Okay, we'll see you later now. Bye.